everyone, this is Sahiti on behalf of Edureka, and today's session is all about database management systems and MySQL. So now without wasting any further time, let's just get started with the MySQL tutorial so that you guys understand what exactly MySQL is and start playing with your databases, right? So first of all, let's look into the topics for today's session. We'll start today's session by understanding the very basic ideology that is data, then we'll understand databases, and then finally we'll understand database management system. Once you understand this, I'll make you go through the entity relationship diagrams, normalizations, the various SQL commands, and also various other concepts of SQL such as views, triggers, procedures, and many others. So don't worry guys, in this session you'll be learning all about database management systems and MySQL. So now without wasting any further time, let's just get started with the session now. So now, as all of us know that quintance of data is all around us. But what exactly does this data term mean? Have you thought about it? Well, you can consider the example that you can see on the screen. Imagine there are around hundreds of employees working in a company. Now, obviously, each employee has their own name and they have to get identified with their names in the departments, right? So, all of these names identifying each of these employees with their departments, where are they working, in what position, everything together forms data. So, if I just have to define it for you, well, I can say that data is basically distinct pieces of information or collection of facts related to any particular entity. It could be either an employee or it could be either object or anything, right? So that's how you can basically understand data. It's just a collection of facts that defines any particular entity. Now, how do you think the company stores so much amount of data all together to identify all the employees? Well, that's obviously through a database, right? So you can consider a database as a container wherein all the data is stored. So database is basically a systematic collection of the data which supports the storage and manipulation of the data that you've stored. So in simple terms, if you have to understand database, then just consider it like a container wherein your data is stored, right? Now, having such amount of data obviously causes a problem when you do not manage it properly, right? So to manage your data in the databases, you need something known as the database management systems. But what exactly do you think these database management systems are? Well, database management systems is basically a collection of programs which enables its users to access the database, manipulate the data, report or represent the data. So you can play around with your data when you have a proper database management system and you can obviously manipulate it. So if you have to just understand the term database management system, then in simple terms, you can say that it's a collection of programs which enables the users to access data, manipulate data, and represent data, as I said before. Or you can also understand that it's a technology to store and retrieve the data with the utmost efficiency along with its appropriate security measures. So guys, that's how you can understand data, databases, and database management system. Now, as I was talking about database management system, you must be wondering, right? What are the various kinds of database management system? Because there are various types of data stored, and every kind of data has different kinds of relations, right? So to manage this, you need various kinds of database management systems. So mainly there are around four types of database management systems. That is the hierarchical database management system, the network database management system, the relational database management system, and the object oriented database management system. So starting with the hierarchical database management system, basically this type of database management system employs the parent child relationship of storing data. So as you can understand with the name, it basically stores the parent child relationship of storing data, right? So this type of DBMS or database management system is obviously rarely used nowadays. Also, let me tell you that its structure is like a tree with nodes representing the records and the branches representing their fields. So for example, if you have to understand this hierarchical database management system, then you can say the Windows registry used in the Windows XP is an example of this. So basically all the configuration settings are stored as the tree structures with the nodes. Now moving on to the network database management system. Well, this type of DBMS mainly supports many-to-many relations. So this usually results in a complex database structure, and I can say that the RDM server is an example of this kind of DBMS, right? Now moving on to the relational DBMS. Well, the relational DBMS, as the name suggests, defines the database relationships in the form of tables, also known as relations. So unlike the network database management system, the relational database management system does not support many-to-many relationships. It usually has a predefined data types that they can support, and I can say that this is the most popular DBMS today in the market, right? So if you ask me your example for this, then I could say that the Microsoft SQL Server database are all the examples for this kind of DBMS. Now moving on to the final DBMS, that is the object oriented DBMS. Well, this type of DBMS mainly supports the storage of new data types. So the data to be stored is in the form of the objects, and the objects to be stored in the database have their own attributes and methods so that they define what they have to do with the data, right? So an example to this particular type of DBMS is the PostgreSQL, right? So guys, that were all the different types of DBMS. You have hierarchical, network, relational, and object oriented, right? So now that you have an understanding of what data is, what database is, and the management and the various kinds of management systems, it's time that we jump into SQL so that you understand what the structured query language is, and then you start playing with your databases. So let's get started with it. So starting with what is SQL, that is basically structured query language. Well, it's basically a standardized programming language which is used for managing relational databases. With SQL, let me tell you that you can modify databases, you can add or update or delete any number of rows of data. You can also retrieve the subsets of information from a database and many more actions, right? So you can play around with your databases a lot. Now, not only this, but the SQL language is also used in relational databases such as the MySQL databases, the Oracle, the MySQL Server, the Sybase, and many more. Now, how do you think all this happens? Well, that happens because of the queries that we use in the SQL language. So, with queries and other SQL operations such as select, insert, add, update, delete, create, and many more, you can retrieve whatever data that you want. So, guys, that was about SQL. So, as I was talking about the structured query language, you must have noticed that, I mentioned about MySQL. Well, as this tutorial is about MySQL and you have understood all the basics before you start with MySQL, let's just get started with MySQL now. So, what exactly is MySQL? Well, let me tell you that MySQL is basically a relational database management system. So, by relational database management system, as I mentioned before, they work with tables and then you define relations between the tables. And it is also an open source software. It provides multi-user access, so you can know that many number of users can use this particular database management system and retrieve the data. MySQL also supports multi-storage engines and works on many platforms, right? So, in simple terms, if you just have to understand in a single line, then it is a relational database management system which is open source, works on many platforms, provides multi user access, and also supports multi storage engines. So, now that I've told you about MySQL, let's just look into the features of MySQL so that you get a clear understanding of why exactly we should use MySQL. So, as you can see on the screen, these are the various features of MySQL. It provides ease of management, it provides robust transactional support. It also provides comprehensive application development. It provides high performance. It also makes sure that you have a low total cost of ownership. It's an open source software with 24/7 support. It protects your data, it is highly available and is also very scalable and flexible. So these were the features of MySQL. Now that you've understood what MySQL is and what are the features of MySQL, let me just show you how to interact with MySQL, for which you'll need a server access tool that can communicate with your MySQL server, and that is MySQL Workbench. So basically, MySQL Workbench is a visual database designing and modeling access tool for MySQL Server relational databases. It facilitates creation of new physical data models and also allows the modification of existing MySQL databases with reverse or forward engineering and change management functions. So let me just open my MySQL Workbench so that you understand and see how that it goes. So let's just open it. All right. Yes. So as you can see on the screen, this is the dashboard of MySQL Workbench. It mainly has three modules. That is, the first one is for the SQL development for working with queries, tables, data and scripts. And then we have the second module that is basically the data modeling for designing database modules and diagrams. And then we have the third one that is the administration of server. So this is basically used to monitor and secure and also configure your servers. So these are the basic three modules of the MySQL Workbench that you can see on the screen over here. Now let me tell you over here that the Workbench is available for Windows, Linux, Mac OS, either on the 32-bit or on the 64-bit as you wish so. So guys, if you want to learn more about MySQL Workbench and you want to explore what all you can do with it, you can go through the documentation link that is over here and then you can start learning about it. So now let me just use the SQL development and then let me just create a new connection to a server instance and then, let's start creating new databases and tables, right? So for that, I'll just, choose this option that is the SQL development and then I'll go to the plus option over here that is basically to add the MySQL connection. Choose this option. So once you choose that option, you'll see that you have to fill in some details. So let's say I fill in the connection name to be edureka, the method to be same. Let's say the host name stands same, the port is 3306, username is root. Let's say we store the password to be whatever password that I've mentioned, and then we also have an option to create a default schema, right? So when you mention some schema, that schema would be created and it will be used as your default schema. So presently I'm not going to do that, and then I'll just click on OK. So once you click on OK, you can see that your new connection has been added. So let's just open this connection and see. Okay. So you can see that your connection opens and this is how the dashboard looks. So basically you have four panes. That is the basic pane where you have various options to add a query database. You can configure your servers and all. In the left side, you have a navigator pane where you can see the performance, instance, and management. At the bottom side, you see an output pane wherein you see all the outputs for the queries that you've mentioned. And on the right side, we have the SQL additions pane, right? So let me tell you one more thing over here. That is, you can hide any of the panes that you want. So suppose if I want to hide the right side pane, so I'll just click on this option and you can see that, the right side pane has been hidden. Similarly, you can do for the bottom pane and also the left side pane. So if I just do that, you'll see that, all my panes are just hidden and only I just have is the editor to just write my queries. So let me just get all my panes back. So I'll just get in all these panes. All right. So, well, we can start writing queries, but before we get into the queries part, let me just shift back to my presentation so that I explain you more about the command categories and many more stuff, and then we'll get back to this, right? So let's just go back. So now let's just quickly discuss the SQL command categories. So basically there are four command categories, that is the data definition language, the data manipulation language, the data control language, and the transaction control language. So the commands coming under the data definition language basically are used to define the database schema. So you have your create, drop, alter, truncate, comment, rename, all these kinds of commands in the data definition language. Coming to the manipulation language, all the commands that deal with the manipulation of data present in the database come under this particular section. So you have select, insert, update, delete, and many more in this section. Now, the data control language includes all the commands which mainly deal with the rights and permissions and other controls of the database system. So any permission that you want to grant to your database or any kind of right that you want to give, then you have to use the commands in this particular category, which are mainly the grant and invoke. And finally, we have the transaction control language, which includes the commands which mainly deal with the transactions of database. So you have your commit, rollback, save point, set transaction commands in this transaction control language. So guys, these are the main four categories of the SQL commands. You have your data definition language commands, the data manipulation language commands, the data control language commands, and the transaction control language commands. So guys, I hope that it's clear to you, right? So now that you've understood the basic database concepts, what exactly SQL is, and then MySQL and the various SQL command categories, it's time that we start understanding how to perform the data modeling. So when I say data modeling, I'm basically talking about how do you design your database. So mainly there are two ways. Either you normalize your complete database or you use the entity relationship diagram. We'll start with the entity relationship diagram, that is also known as the ER diagram. As you can see on the screen, this is an example of an ER diagram that I'm going to explain you. But before that, let me just tell you what exactly ER diagram is, right? So ER diagram or an entity relationship diagram is basically a diagram wherein you represent real world objects as entities and then you understand the relationship between them. So how they are dependent on each other, what kind of attributes do they have, how is one object or one entity dependent on the other entity, and so on. So you can understand all these relationships with the help of ER diagram. So let me just, make you go through this particular ER diagram that you can see on the screen. So this ER diagram is basically for a company database. So as you can see, we have the employee, departments, and the project as the main entities. So if you have to represent an entity, then you put it in a rectangular box, and then you can see that employee, department, projects are the main entities. So the complete ER diagram would be based on them. So an employee has a social security number, which is basically an employee ID through which that particular employee can be identified. An employee also has a birth date. An employee will obviously have a name also, who has the first name, middle name, and also a last name. An employer has an address, salary, and a gender, right? So an employee can be identified by looking into all these attributes. Now, similarly, when you come to a department has a department name and a department number through which it can be uniquely identified. So, suppose in your company you have your tech department, right? A tech department will have its own department number and the department name and the department's location also, right? And then we have the project entity. So, a project can also be identified with the project name, project number, and where was the project taken, right? So, where did the project happen? We have the name, number, and the locations over here. All right, so that was about entities. Now when I say relationship is basically the relationship between two entities, right? So as you see, the employees and the department have this particular relationship, that is works for and manages. The employee and the project have the works on relationship, and the employee and dependent have the dependence of relationship, right? So before I move into relationship, let me just talk about the weak entities over here. Well, as you can see on the screen, the dependent entity is basically a weak entity. So when I say a weak entity, I mean that this particular entity is completely dependent on the strong entity, that is basically the employee entity. Now you must be wondering, right, why do we have this dependent entity? Well, dependent entity basically keeps a track of each employee's insurance purposes, or you can say any official purposes, right? So as I said before, as this particular entity is completely dependent on this, so for any kind of insurance purposes, we obviously need all the details of the employees, right? So suppose if you have to get an insurance done, then the insurance policy needs your name, address, birthday, salary, the gender, and so on, right? So all this data can be taken from this particular entity's attributes. So that's the reason this particular entity, that is a dependent entity, is a weak entity which is completely dependent on the employee entity. So now that you've understood the weak entity, let me just tell you that the relationship between a strong entity and a weak entity will be a weak relationship. So a weak relationship is basically represented like this, right? Now coming to the strong relationships, as you can see, the works for relationship, the managers relationship, the works on relationship, and the supervision relationships are basically the strong relationships. That's because these are the relationships between two strong entities, right? So now let me just tell you how are these relationships happening between all these entities. Coming to the first relationship, that is the works for relationship. Well, as you know, every employee works for some or the other department, right? So that's how this particular relationship is. That's basically a strong relationship. And then we have the employee managers department. Now there could be some employees, who have become the managers of some particular department, or they lead the department, right? That is basically another type of relationship between these two entities. So suppose you have 10 employees. So there could be 9 employees who are working for the department, and there could be one employee who manages the department, right? So for the manager's relationship, we have a separate attribute, that is the start date. So by which we can understand that, suppose X employee with all these attributes has started managing the Y department from today. So with such kind of information, we can start understanding that, the X employee has started managing the Y department from this particular date, right? Now moving on to the next relationship, that is works on. Now, obviously, for every employee working in some or the other department will obviously work for a project. So obviously, employee and project entities are connected to each other with the works on relationship. So suppose you can say that, an ex-employee works on a Y project and is from this particular department. So employee, department, project, all are connected together, right? Now you must have seen that works on relationship has its own attribute, that is ours. So with this attribute you can get a clear understanding that suppose X employee works on Y project for so many hours, right? Now moving on to the next relationship, that is between the department entity and the project entity, we have the controls relationship, right? So it's obvious. So in a company, a department can handle 10 projects and any other department can handle different number of projects. So it's basically like, a tech department handles 10 projects with XYZ names, or you can say the marketing department is handling 10 projects with XYZ names and so on, right? So that's how these two entities are connected. And let me tell you one more thing over here. There's a self relationship over here, right? So you must be wondering over here, right? How is an employee related to an employee himself? So when you work with your boss in a company, both you and your boss are two employees of the company, right? So basically, you and your boss are connected to each other with this particular kind of relationship, that is supervision, and both of you have your own attributes. So suppose X is the supervisor and the Y is the supervisee. X supervisions Y, right? So that's how this particular relationship has come into place. So I hope that you guys have understood what entities are, what relationships are, what weak entities are, what strong entities are, right? Now let me tell you one more thing over here. You must be wondering, what are these numbers over here? N is to 1, 1 is to n, m is to n, and so on, right? Well, that's basically the cardinality ratios. So let me just explain you with some examples over here. So suppose if you understand this particular relationship, that is the employee works for department. So there could be n number of employees working for a single department, right? So suppose you have 100 employees working for tech department. That could be completely possible, right? So that's the reason we have given a cardinality ratio of n is to 1 over here. Now similarly, let me just go through all the other cardinality ratios over here. So a single employee works for one particular department only, right? So suppose if I work for the tech department, right? So I work for one department. So I myself, that is basically an employee, work for the tech department. Now similarly, an employee can work for n number of projects, or m number of employees can work for n number of projects, right? So a group of 10 can work for 20 projects, or you single-handedly can work for 5 projects, right? So that's how comes the cardinality ratio between employee and project to be m is to n. Now, the relationship between employee and dependent shows 1 is to n, right? So, a single employee can have n number of insurances, right? So, he can have a house insurance, he can have an health insurance, or he can have a car insurance. So, suppose an ex employee has 3 insurances. So, you have to mention all the details of all kinds of insurances over here. That's how the relationship between employee and dependent has 1 is to n ratio. And also coming to the self relationship, that is the supervision relationship between two employees. A single supervisor can supervise around 10 employees or hundreds of employees, right? So guys, that was all about cardinality. You have one to one to many to one, and many to many relationships. So now moving on to the participation, that is the participation between entities. You must be observing this double lines and single lines over here, right? So that's what I'm talking about. So the double lines between the entities basically represent the total participation, and the single lines basically represent the partial participation. So let me just start with the total participation first. So when I talk about total participation between both the entities, I mean that both the entities are equally involved in this kind of relationship. So when you want to know which employee works for which department, then both these entities, that is the employee entity and the department entity, have to work in together. But when it comes to partial participation, then not all the entities are involved in this relationship. So if you consider the participation between employee and department with the relationship manages, not all employees manage the department, right? So all the employees over here do not come into this relationship. Only few employees come into this particular relationship. So that's the reason this is the participation of employees in the manager's relationship is partial. All right. So if you consider the participation of employees in the manager's relations, then not all the employees are involved, right? So that is the reason this has partial participation. But yes, we need the details of all the departments, right? So that's the reason the department side shows the total participation. Now, similarly, if you consider the relationship between employees, project, and on the relationship works on, all the employees work on some or the other project, right? So that is the reason the employees and the works on have the total participation. And also, since all the employees work on some or the other projects, the relationship between works on and project is also total participation. Now, coming to the relationship between employee and dependent, as we all know that employee is a strong entity and dependent is a weak entity. The weak entity is completely dependent on the strong entity. So that's the reason this shows total participation and this shows partial participation. It could be possible that not all the employees have insurances, right? That's also another reason that shows that the employees have partial participation and the dependent entity has a total participation in this kind of relationship. So guys, that was all about participations. Now you guys must be wondering, right, that attributes that I just spoke about when I was talking about entities, so some are in different color, some are mentioned with a double oval and so on, right? So let's just discuss each one of these attributes one by one. So an ER diagram can have a composite attribute, a simple attribute, a single attribute, or a multi-valued attribute, stored attributes or derived attributes, and also complex attributes. So we'll start with the composite versus simple attributes. Well, composite attributes are basically those attributes which can be divided into small subparts. Now then each of the subparts basically represent individual basic attributes with their own meanings. But when it comes to the simple attributes, they're already simple. You cannot divide them further, right? So if you consider the example on the screen over here, the address attribute can be further divided into the street address, city, state, and zip. And also this particular attribute, that is the street address, can be also further divided into number, street, and house number. So the address attribute and the street address are basically the composite attributes, but the city, state, zip, the street number, house number all come into the section of simple attributes as these cannot be divided further, right? So if you look into your ER diagram, you can see that the name attribute is basically a composite attributes because yes, the name can be further divided into first name, middle name, and last name. But yes, the SSN, the birthday, the salary, sex, start date, hours, and all cannot be divided further, right? So all these are basically the simple attributes. So I hope that's clear to you guys. Now moving on to the next attributes type, that is the single versus multi-valued attributes. So single attributes are those attributes which have a single value for a particular entity, but when it comes to the multi-valued attributes, a multi-valued attribute may have a lower and an upper bound to constrain the number of values allowed for each individual entity. So let me just show you in the ER diagram. So as you can see on the screen, the locations is basically a multi-valued attribute. So as I mentioned before, a multi-valued attribute may have lower and upper bounds to constrain the number of values. So, when it comes to locations, a department can have n number of locations, right? So you can say that the department is located from floor number 1 to floor number 5, right? So 5 floors are for this particular department. So that's the reason the location is basically a multi-valued attribute. Now let's just move on and see the next kind of attributes that are basically the stored and the derived attributes. So guys, as the name suggests, the attributes which are derived from the real entities are known as derived attributes, and the stored attributes are those attributes, or you can say such attributes, which are already stored in the database. So basically, stored attributes are those attributes from which the value of another attribute is derived, right? So if you consider this example of age and birthday, then you'll observe that the birth date is basically a stored attribute, and obviously the age of a person can be derived when we come to know the birth date, right? So suppose I'm born in 1996, so you can roughly get an idea that I'm already 22 years old. So the age attribute is basically the derived attribute over here, and the birth date attribute is basically the stored attribute over here. So now let me also mention over here that the derived attributes are mentioned with a dashed oval. So let me just open our ER diagram and show you. So as you can see in our ER diagram that the number of employees are basically the derived attributes over here, right? So when you have the department name, number, and the location, you can obviously derive how many employees are working for this particular department from the relationships over here, right? So that's how number of employees is basically a derived attribute over here. Now, moving on to the final kind of attributes, that is basically the complex attributes. So, complex attributes are basically those attributes which can be represented by grouping composite attributes between parentheses, separating the components with commas, and also displaying multi-valued attributes between square brackets. So, as you can see in the example over here, so the address phone is basically a complex attribute which has a phone attribute which is basically a composite attribute, as a phone attribute can be divided into area code and phone number. And then we also have an address attribute, which is a composite attribute, which can be further divided into street address, number street, flat number, city, state, and zip, right? So the address phone over here is the complex attribute, and the phone and address are basically the composite attributes. So guys, basically these kind of attributes are generally used while you draw your ER diagrams. Guys, this was all about the ER diagram, or you can say the entity relationship diagram that you have to understand about. So all the entities, all the relationships, all the attributes, there are different kinds of cardinality ratios, different kinds of participation, there are different kinds of entities, relationships, and so on, right? But there's also one more thing that I missed out over here. That is basically, you must have observed that I've underlined the text under few attributes. So for example, employees SSN has been underlined, and also dependents name has been underlined, projects name and number have been underlined, department name and number have been underlined, and so on, right? Why have I underlined this? I'll let you know, you guys, later on. These are basically the keys, and keys are basically how you can identify these entities, right? So we'll talk about that later on. But before that, let me just cover a few more topics, that is the entity types, entity sets, keys, and value sets. All right. So as you can see on the screen, just consider this example to understand the key terms: entity types, sets, keys, and value sets, right? So we basically have two entities, that is the employee entity and the company entity over here. Now this is basically the entity type name. These are basically two entities over here. Then we have the entity type name, that is basically the various attributes of this particular entity, right? So we have the name, age, salary for an employee, and name, headquarters, owner for a company. So these are basically the entity types. Now, when you talk about entity sets is basically, to store the values in an entities, right? So you can have various employees and their information. So suppose an entity set consists of so many values. I'll store the name first because I've mentioned name, age, salary, right? So in the entity set, you have to mention in the same order. So I'll mention the name, the age, salary. Similarly, I'll mention for another employee, that is the name, age, salary, and so on. And the same goes with the company. So over here, I've mentioned the name, headquarters, owner. So similarly, for a company, I'll just write in the set that the company's name, the headquarters, and the owner's name, right? So that's what basically entity type and entity set is. Entity type is how you define an entity and how you mention all the values. Basically, in what order do you want the values to be put into the entity set? And entity set is you put in all the values, right? Now, coming to keys and value sets, I'll tell you about keys next, but before that, let me just tell you what value sets mean, right? By value sets, I mean that, whatever you have mentioned over here. So every entity has some or the other values, right? So suppose you have employees entity, right? So the employees have their own attributes, and you can have thousands of employees details in it. So the complete information of employees will be the entity set, and the information that you have stored for each particular employee will be basically the values, right? So each entity will have its own values, and you can store n number of values based on whatever information or whatever attributes that you've mentioned. Now let's just move on to keys, guys. All right, guys. So now let's look into the various kinds of keys in a relational database. There are mainly five types of keys in a relational database, that is the candidate key, the super key, the primary key, alternate key, and the foreign key. So we'll be discussing each one of them one by one, but let me tell you one more thing over here, that we'll be using this particular example that you can see on the screen to understand all these keys, right? So let's just get started with the various kinds of keys. So starting with the candidate key is basically a minimal set of attributes which can uniquely identify a tuple, right? So the value of the candidate key will be unique and non-null for every tuple. That means the tuple that is identified as a candidate key needs all the values to be present. There cannot be any null value present. And also there can be more than one candidate key in a relation. So a candidate key can also be either a simple key or a composite key. Now, when I say candidate key, so if you see the example over here, the employee number is basically a candidate key, as this uniquely identifies all the employees and also which employee is working for which department, right? Also, let me tell you that in a SQL server, a unique constraint that has a nullable column, that is basically which can be a null or not, allows the null value in that column for only once, right? So that means the employee phone is also basically a candidate key. But yes, when a candidate key is chosen to be a primary key, it cannot have any null values, right? So if I have to just repeat it for you, then a candidate key is basically a minimal set of attributes which can uniquely identify a tuple, right? So here we have the employee number and the employee phone as the candidate keys. Now moving on to the super key is basically a set of attributes which can uniquely identify a tuple. Now you must be wondering, it's similar to candidate key, right? Well, yes. So as you can see on the screen, the employee number, the employee name together can be taken as a super key so that they uniquely identify any particular tuple, right? So 1 and Rohan can identify the complete tuple over here. 2 and Rohan can also identify the complete tuple over here. So you can clearly see that there are two Rohans who belong to two different states and have two different phone numbers, right? So the employee ID, that is basically the employee number, and the employee name can together act as a super key and identify a tuple, right? Now moving on to the primary key. There can be more than one candidate key in a relation, out of which one can be chosen as a primary key. So suppose you have two, three candidate keys, right? So out of those two, three candidate keys, one can be chosen as a primary key. But let me tell you over here that a primary key cannot have any null values in its tuple. So for example, as I mentioned before, we have the employee number and the employee phone number as the candidate keys. So out of these, any one of them can be chosen as a primary key. So let's just say if I choose employee number as primary key, then we just have to make sure that none of these values have a null value. So that was all about primary key, guys. Now moving on to the alternate key. The candidate key other than the primary key is basically known as alternate keys. So suppose if you have two, three candidate keys, right? Out of which you'll choose one key as your primary key and the rest keys will be basically known as the alternate key. So in the example that we saw before, where we have the employee number and the employee phone number as the candidate keys, if we choose the employee number to be our primary key, then employee phone number would be our alternate key, and the vice versa. So guys, that was about alternate key. Now moving on to the foreign keys. Well, to understand foreign keys, you have to understand the fact that if an attribute can only take the values which are present as values of some other attributes, then it will basically be the foreign key to the attribute to which it refers, right? So basically, the relation which is being referenced is called the referenced relation, and corresponding attribute is called the referenced attribute. And the relation which refers to the referenced relation is called the referencing relation, and the corresponding attribute is called the referencing attribute, right? So the referenced attribute of a referencing attribute should be a primary key. So in the example that you can see on the screen, the employee number in the employee department table is basically a foreign key to the employee number in the employee relation. So guys, that was all about the various kinds of keys in a relational database. So now that you've understood so much about entity relationship diagram, it's time that you also understand what exactly normalization is. So if I have to define normalization for you, well, normalization is basically a technique that organizes tables in such a way that the redundancy and the dependency of the data is reduced. So in other words, you can say that normalization is basically a technique of data modeling again. So there are mainly four normal forms, that is the 1NF, 2NF, 3NF, BCNF. But this is not the end to the story, guys. You can also have further normal forms such as the 4NF, 5NF, and the 6NF, right? So basically, the levels of normal forms goes until you organize a table in such a way that your redundancy and dependency of data is reduced, right? So suppose if all your tables are organized by 2NF, so you need not go to 3NF and BCNF. Similarly, if your tables are still not organized till BCNF, then you still have to go for higher normal forms such as 4NF, 5NF, and 6NF, right? So let's just get started with 1NF, 2NF, 3NF, and BCNF. So let's just move on. So guys, I'm going to consider this particular example to explain you the complete normal forms, that is the 1NF, 2NF, 3NF, and BCNF. So we have a database of a video library which maintains all the data of the movies rented out. So we have a table of salutation, full name, address, movies rented, and category. So we have Miss Alice Johnson residing in this particular address renting out two movies, that is Mission Impossible and Clash of Titans. Similarly, Mr. David Allen, whose address has been divided, that means it's a composite key that is being used that I mentioned before, right? So you can divide your addresses further, right? So this is basically a composite key. And he has rented out three movies, that is Interstellar, Edge of Tomorrow, and Mission Impossible. Now, when you talk about normalization, you'll start with the first normalization, that is the 1NF. So the only rule of 1NF, that is basically the first normal form, is that each table cell should have a single value. So basically what it means is that all the records must be unique, right? So whatever table that we just saw before, that is basically the example table that I was just showing you, the tables have two values in one single cell, right? So basically we have to divide this table in such a way that each cell has only single value. So our first normalized table would be something like that, Miss Alice Johnson residing in this particular address has rented out Mission Impossible. Similarly, we'll have another tuple of Miss Alice Johnson residing in this particular address, renting out Clash of Titans. So similarly, we'll have it for David Allen, who's residing in the 3rd Street 45, renting out Interstellar. And then we'll have another tuple of Mr. David Allen renting out Edge of Tomorrow. So let's just look into our first normalized table. So as you can see, our table has been divided in such a way that each cell has a single value. So as you can see, Miss Alice Johnson residing in this particular address has rented out Mission Impossible. Similarly, we have another tuple of Miss Alice Johnson residing in this particular address, renting out Clash of Titans. And similarly, we have the details for David Allen, right? So guys, that was about 1NF. That is basically the first normal form. Now, if you observe in our table, you'll observe that, David Allen's address is a composite address. That's basically, the address has been divided into two parts, right? So this is basically a composite key, or you can say the composite attribute that I was telling you before. Now, what we want is we want the full name and full address of a person renting out movies, right? But in the first normalized table, you observe that David Allen's information is getting discreted, right? It's not that we have the full address of David Allen, right? So to get both full name and full address, what we need is we need the table to be normalized into a second normal form, right? So let's just jump into second normalized form now. Okay. So the rule of second normal form is that the database should be in the first normal form, and it should also have a single column primary key. So when I say single column primary key, I mean that it cannot have composite keys. So what I've done now is I've divided my first normalized table that I showed you before into two different tables, that is table 1 and table 2. So the table 1 has an ID that I've introduced over here, identifying each particular person uniquely with the matter of their full name and address. So you can see that Miss Alice Johnson has been given an ID of 1. Mr. David Allen residing in this particular address, that is basically a composite address, has been given an ID 2. And also Mr. David Allen having this particular address has been given the ID 3, right? And in the second table, what we've mentioned is we've mentioned the IDs and we've mentioned the movies rented by these particular users. So with Alice Johnson with ID 1 has rented out Mission Impossible. Alice Johnson again with ID 1 has rented out Clash of Titans. David Allen living in the 3rd Street has an ID 2 and has rented out Interstellar. Similarly, David Allen of ID 2 has rented out Edge of Tomorrow. But yes, David Allen with ID 3, that's because of the composite attribute over here, has rented out Mission Impossible. So that's how basically, you can go to the second normal form by dividing the first normal form's table into various tables, right? So over here, I've just divided into two tables where table 1 contains the member information and table 2 contains the information on movies rented, right? So over here, the ID is basically the primary key for table 1, and records of table 1 can be uniquely identified with this particular ID, and also this particular ID can be used to find out the movies rented by the respective records. So if you just observe over here, this ID in the table 2 is basically a foreign key to this particular ID in table 1, right? So guys, that was all about the second normal form. Before we move on to the third normal form, you have to understand something known as the transitive functional dependencies. So what I mean by transitive functional dependencies is that suppose you change the full name of any particular person, right? So suppose you change David Allen to Monica Allen. So that means the salutation will change over here. So basically a transitive functional dependency is when changing a non-key column might cause any of the other non-key columns also to change. So since our full name is a non-key column and our ID is a key column, if I change the values over here, if I change it to Monica Allen, as I said before, it will obviously change the salutation, right? So this is basically what is known as transitive functional dependencies. Now, if you're wondering why did I explain transitive functional dependencies, that's because in the third normal form, the database should be in the second normal form and it must not have any transitive functional dependencies. So if you observe in our particular tables, that is in the tables of the second normal form, you'll see that, our ID columns are basically the primary key column, right? And salutation, full name, address are basically the non-key columns. So suppose if I change the name over here, let's say Monica Allen, that is basically I'm changing a non-key column, then it will obviously automatically change my salutation, right? So it will obviously automatically change my salutation to Miss over here. And this is obviously a transitive functional dependency. But since we want to avoid the transitive functional dependencies in the third normal form, so what I'll basically do is I'll have three tables over here, with the first table showing the member ID that we had as a primary key column in the second normalized form, the full name, that is basically all the full names of all the people renting out the movies, the address, and then we'll introduce the salutation ID. And in the table 2, we'll have the ID, that is basically the member primary key ID that we have in the second normalized form, and also the movies rented table. And in the third table, what we'll do is we'll basically take the salutation ID and salutation into account, right? So the third table will basically have the salutation ID and salutation. So each and every person having some particular salutation will be assigned an ID, right? So if it's a Mr., he'll be assigned an ID 1. If the salutation is a Miss, then the ID assigned will be 2. Similarly for Mrs., it would be 3, and Doctor would be 4, right? So with this, we'll make sure that there are no transitive functional dependencies, and hence all our tables are in 3NF. So guys, that's how you can make sure that your tables are in 3NF. Now one more thing over here is that the table 3 salutation ID is basically a primary key, and the table 1 salutation ID is basically a foreign key to this particular primary key in table 3, right? So that's how the relationship between the primary key and the foreign key goes on. All right. Now, guys, if you observe over here, our example has come to an end, and you can clearly see that you cannot decompose it further to attain any higher normal forms, right? So that means our example is in the highest normal form for itself, and it is in the third NF. But yes, if you want to go to the higher normal forms, that is basically the PCNF. PCNF is basically used, when a database is in a third normal form, but yes, there are few more anomalies left, and yes, it has more than one candidate key, right? So that's when the PCNF is used, and that's when you start dividing your tables further so that you have only one candidate key present and you have all the anomalies removed. These were the few normal forms. Apart from this, if your database is still not sorted out and it still needs to be organized, then you can go further and try out the fourth normal form, the fifth normal form, and the sixth normal form. So guys, that was all about normalization. So now that I've told you so much about databases, how you model your data, how you play around with it, what exactly are we going to use to connect to our MySQL, how do we understand the ER diagram, or how do we normalize the data, it's the time that we start understanding the SQL commands, so that you start writing your own queries, and then you start creating your own databases and play around with them. So before I start with the commands, let me just discuss the data types and the constraints that would be needed for you to write the queries. So the SQL supports all these data types that you can see on the screen. You have the numeric data type, the character string, the bit string, the boolean data type, the date and time data type, and the timestamp, right? So the numeric data type allows the integer, small int, float, real, double, precision, and the decimal. So that's basically all the numeric values that you want to enter, and also the floating point values that you want to enter, and also the character large objects, so that you store large amount of characters in your database. It also allows the bit string data type, so you can have bits of varying size or bit of n size. You can have boolean values, that is the true, false, unknown. You can store date and time, and also the timestamps. Also, let me just introduce you to the constraints, so that when I start writing the queries, you do not have a confusion why are we mentioning these constraints. So if you have to first understand what exactly constraints are. So basically, constraints in simple terms are those rules that can be applied on the type of the data in the table, right? So it could be either not null, it could be unique, it could be check, it could be default, or it could be index. So the not null constraint is basically used to ensure that the null value cannot be stored in a column. The unique constraint makes sure that all the values in that particular column are different. The check constraint ensures that all the values in a column satisfy a specific condition that you'll mention. The default constraint consists of a set of default values for a column when no value is specified, right? So suppose if you mention the default constraint, it will just choose the default value when you do not mention any value for that particular column. Last but not the least, we also have the index constraint, which is used to create and retrieve data from the database very quickly, right? So we have the not null, unique, check, default, and the index constraints. So I hope that it's clear to you guys. So I'm just going to first give you the overview of all the commands, and then we'll move on to MySQL Workbench, and then we'll use these commands, right? So first, let's just look into the SQL data definition commands. So as you can see on the screen, all these are basically the commands for the data definition. So you have the create index, which basically creates an index for a table, or the table that modifies a table's definition. So you can basically add, modify, or delete any attributes or constraints that you want. The drop table basically permanently deletes the table and all its data. The create schema authorization is basically creating a database schema. The create table is to create a new table in the user's database schema. Now, under the create table, you can use all the constraints that I mentioned before. That is the not null, unique, primary key, foreign key, default key, and check key. You can use the drop view to permanently delete a view, the drop index to permanently delete an index. You can also use a create view to basically create a dynamic subset of rows or columns from one or more tables. So don't worry guys, we'll be discussing about views very soon. And we can also use create table as, that is basically create a new table based on the query in the user's database schema, right? So these are basically the data definition commands that you can use. Now moving on to the data manipulation commands, you can use the update command, which is basically used to update any attribute value in one or more table rows, the commit command to permanently save the data changes, the insert command to insert a new row in the table, the select command, which basically selects attributes from rows in one or more tables of views. So in select, you can use the where, group by, having, and order by. The where command is basically used to restrict the selection of rows based on a conditional expression. The group by command is basically used to group the selected rows based on one or more attributes. The having command restricts the selection of grouped rows based on one condition, and the order by command is used to order the selected rows based on one or more attributes, right? Now, not only this, but you can also use the delete command to delete one or more rows or tables, the rollback command to restore data into their original values. And you also have many more commands, such as the logical operators, which are basically and or not, which are used in the conditional expressions, and the comparison operators that you can see on the screen, that is equal to, less than, less than equal to, greater than equal to, and so on, which are again used in the conditional expressions. The aggregate functions such as the count, min, max, sum, average, which basically are used as the aggregate function. So with the count function, you can return the number of rows with non-null values for a given column. The min function is used to return the minimum attribute value found in a given column. The max is used to return the maximum attribute value found in a given column. The sum is used to return all values for a given column. The average is used to return average of all values for a given column. The special operators are again used in the conditional expressions, and their between is null, like, in, exists, and distinct. So the between operator basically checks when an attribute value is within a range. The is null checks whether an attribute value is null or not. The like operator is used to check whether an attribute value matches to a given string pattern or not. The in operator checks whether an attribute value matches any value with the value list. The exist operator checks whether a subquery returns any rows. The distinct operator limits to unique values, right? So guys, these are few data manipulation commands and data definition commands. Now let's just quickly shift to our MySQL workbench and let's just see how we can play around with these commands. Alright guys, so let's get started with our MySQL workbench. So I'm going to use the same connection that I just created before. So let me just open that. Alright, so now when you open your connection, you'll see a dashboard like this, right? So let me just enable all the panels over here so that you can see all the panels. So as you can see on the screen, guys, this is how your MySQL workbench looks like. So now let me just add a query editor so that we can write our query. So for that, you'll go to File and you'll choose the New Query tab. So this will basically open your New Queries tab, right? Now what we're going to do is we're going to first create our schema, that is basically a database, and that I'm going to create it on the basis of the entity relationship diagram that we just discussed before, right? So let's say I want to create a new schema. So what I'll do is I'll go to this schemas option over here, and then I'll right click over here and choose the option create schema. And then let's say we mention the schema's name to be company. So I'll mention company over here and I'll click on apply. So once you click on apply, you'll see that your SQL script which will be applied will be displayed to you. So that's the command that we want to be applied. So we'll just click on apply over here. Once you see that your SQL script is applied to the database, you'll see an output that executed SQL statements, right? Once you're done with that, just click on finish. So you'll see that your company schema has been created, right? So now once your schema has been created, obviously our next step is to create tables. So to create the tables, we're going to use the create command. So we'll just type in create table. And then let's say we want to create it for the company's database, right? So we'll just mention the database name. So let's say company dot, let's mention the table's name over here. Let's say I mention it to be employee. And then I'll mention all the parameters that I want to mention, right? So let me just go back to my entity relationship diagram over here. So as you can see on the screen, the employee entity has various attributes such as the name, that is the first name, middle name, last name, address, salaries, the gender, that is basically the sex, birth date, and SSN, right? So we're going to mention all these attribute names as the column names, right? So let's just do that. So let's go back over here and let's just type in all the attribute names. So let's say first name to be of varchar types, that is basically it could be a variable length of characters, let's say of 15 characters and not null. That means when I say it's not null, it means that it cannot have a null value. It's mandatory that the column must have some or the other value for every tuple, right? Once you're done with that, you have to mention the other attributes such as last name and all. So let's just mention last name. Let's say it off to be of varchar types again, and let's say again 15 characters, right? And again, let's say that it cannot be null. Now let's also mention the middle name over here, and let's say it is of character types, right? So basically you can only mention a single alphabet over there, right? And let's say it can be null. Now apart from that, let's mention the SSN, which is basically our social security numbers, which will identify all the employees. And let's say it is again of character types, and let's say if 9 characters are allowed, and again not null, because this will be a primary key, and as I mentioned before, the primary key column cannot have any null values, right? Now, once I'm done with that, I'll also mention the birth date of date type. So I'll just mention date over here. And similarly, address of varchar types. Let's say 35 characters are allowed, and again, not null. The gender. So let's just mention sex over here, and character, and it can be null, right? It's not mandatory that the gender is mentioned all the time. Let's again have a parameter of salary of decimal type with a range of 10 to 2 and can be of null types. Now, apart from this, let's also mention the super SSN. Now, when it comes to super SSN, you must have observed that in the entity relationship diagram, we do not have the attribute super SSN. But yes, I'm still mentioning it because you must have observed this relationship of employee related to employees with the supervision relationship, right? So because of this relationship, we need this column name so that we understand who is supervising which employees, right? So I'll just mention that column name also. And let's say it's again of character types, let's say 9, and can be of null. It can sometimes happen that, right, that some employee is not a manager and is not supervising anybody, right? So it can be null. And let's say we mentioned the department number also, because this is our employees table and we need to know which department they're working in, so it will be of integer type, again of not null. And that's all, right? So I guess we've covered up all the attributes that are needed, right? So yes, we've covered up all the attributes. Now let's just go back and let's just mention the primary key. By now, I hope that you guys must have understood what exactly primary key is, right? So what primary key basically is that it uniquely identifies all the tuples over here, right? So in the employee table, we want the SSN column to be the primary key because it is unique for each and every employee, right? So we'll just mention that primary key is SSN, right? So let me just type in SSN over here. All right, and then we'll end it with a semicolon. So guys, this is how you can create your own tables. So let me just run this command and show you. So to run this command, what you have to do is you have to just select the complete section and press on Control Shift Enter. So in the action output, you'll see that your table has been created, right? So don't worry guys, once we insert values into our tables, I'll show you how our table exactly looks, right? Now, apart from this, let's create the tables for all other entities such as the department, project, and dependent. Now, apart from this, let me also tell you that you have to create the tables for works on and the department locations. And that's because, works on is a total participation relationship, right? So you need the values of both the employees and projects for that particular relationship. So that's the reason you have to create a table for that, and also department locations, because this is the multi-valued attribute and you have to store the values of it, right? So let's just start creating it. So similarly, I'll write in the commands for create, let's say, department, right? So I'll just type in create table company dot department. And let's say I'll mention all the attributes names, right? So over here, you can see that we have the D name, D number. For the location, we are creating another table, so that's not required now. So we'll add in D name, D number, and we'll also add in the attributes of the relationships. We'll add in the manager's start date and also the manager SSN so that we understand which employee is the manager of which department, right? So we'll just do that. So we have four attributes to add, that is the number, name, start date, and the manager SSN. So let's just start with that. So I'll just type in. All right. So as you can see, I've mentioned all the values over here, and I've mentioned the primary key to be D number because D number is the department's number which will uniquely identify each department, right? So once this is done, let's just run this program again and you'll see the action output. Now, similarly, I'm going to create all the other tables. But before that, you can also use a command known as the use database. So when you use that command, you'll see that, you don't have to mention this part of the statement. So you can directly mention create table department, right? So let's say, let me use that command. So I'll just type in use and I'll mention company, right? So that is basically a database name. Now, once I'm done with that, I'll just run this command and then you'll see that use company has been executed. So that means we are presently using the company database. So any changes that you make or any query that you run will be executed with respect to this particular database. So now let me just write the commands for creating other tables. So once I've used this command to use the database, we can simply write the create table commands without mentioning the name of the database, right? So I've just mentioned department locations. That's basically my table's name, project, works on, and dependent. Now over here, let me just go through all the tables. So what I've done is in the department's location, I have my D number, D location. That is basically the department number, the department location, and both of them together can act as a primary key. So I've mentioned them together as a primary key over here. And after that, in the projects table, I have the project's name, number, location. That is basically where the project is taking place and which department is handling it. So I'll mention the D num over here. I'll mention the primary key to be the P number, that is basically a project's number. So by that, I mean that, your project number is going to uniquely identify this particular table. And over here, if you observe, we have used a unique constraint, right? So basically, this unique constraint is used when you want to make sure that, all the values in that particular column are unique, right? So we have mentioned it for P name, that is basically a project's name. Now we also have the works on table. So that has the employee SSN that is basically dependent on this particular relationship, right? That is between employee and project. So we need the employees handling the project. So we need the social security number of the employee. So I've mentioned that. And then we have the project number that is basically a primary key of the project table. And also I've added on a new attribute that is hours so that we understand how many hours are spent on that project by that particular employee, right? Now the primary key for this table would be the combination of the social security number of an employee and the project number. And similarly, we have the dependence table, which is completely based on this particular relationship. We need the social security number of the employees, and we also have to make sure that we mention the dependent's name, the sex, the birth date, and the relationship. So those are basically the attributes that I've mentioned over here. So I've mentioned all of them, and the primary key to be again the employee social security number and the dependent's name, right? So guys, that's how you can create your tables. So let me just run all these tables. So I'll just select all of them and I'll run them together. Let me just drag this up. All right. As you can see on the screen in the action output, all your tables have been created, right? All right. So that's how you can create your tables. Now, once all your tables have been created, now let's concentrate on the commands insert, update, delete, alter, and drop, right? So insert command is basically used to insert values into your tables. So let's say I start inserting values for the employee table. So what I'll do is I'll just type in the command insert into, and then if I had not mentioned the command to use the company database, you had to mention the database name, and then you'll mention the table's name into which you want to insert the employees. And over here, you can mention all the column names, right? So let's mention all these column names. So let me just copy them, right? So I've mentioned all the column names. So I'll just close this bracket and then I'll use the keyword values and then I'll mention all the values, right? Let's say I start mentioning the values. So let me just mention some random values, right? So you've seen that, I've used the insert command like this. So to use the insert command, you have to type an insert into, you have to mention the table's name or database.table's name. You can then mention all the column names and then you have to use the keyword values and mention all the values, right? Now, once you're done with that, let's just execute the statement. All right. So you can see in the action output that our values have been inserted into the table, right? So you can insert the values like that. Now you can also use the insert statement without mentioning the column names. So what you have to do is you just can mention it something like this. So I'll just copy paste this and remove this part, right? Now once you remove this part, you can just change the values over here. All right, so I've mentioned all the values as you can see on the screen. Let me just run this particular query and you'll see that these values are also inserted in the employee table, right? All right, so you can see that, it is inserted into. So over here, you can also have one more change. That is, since we're already using the database, you need not have to mention the database.table name, right? So I'll just copy this and let me just change the values again. And now let me just mention employee, right? And over here, I'll mention all the values again, right? So I've mentioned all my values. Now, if we run this particular query, you'll see that again, they're inserted. All right. So you can see that all these values have been inserted into the employee table. So that's how, you can insert values into your table. Now, similarly, I'm going to insert values into all the tables. So let me just write in all the commands and then you'll see that all the values have been inserted into all the tables, right? All right, so you've seen that, I've mentioned all the commands to insert values into department, dependent table, department locations table, project table, and works on table, right? So I've mentioned all the values that are required. So let's just run all these queries. All right, so if I drag the action output, you can clearly see that, all our insert statements have been executed, right? Now, as you know, in the entity relationship diagram, all our entities are related to each other, right? So that means we need a foreign key to be mentioned. But how do you think we're going to mention a foreign key? We can mention a foreign key by using the alter command. So alter command is basically used to alter your tables. So suppose if you want to add a foreign key for the relationship between employee and department, that is the manager's relationship, what we have to do is we have to add a foreign key that is manager SSN, which will reference to the employee SSN because that's from where we get all the social security numbers of employees, right? So what we'll do is we'll use the command alter table and we have to alter the table department, right? So we'll just mention department, that is basically our table's name. Then we'll use the keywords add foreign key and then we'll mention what has to be added as foreign key, right? So I'll just say it to be mgrssn, which references the employee table and it has to reference SSN, right? So I'll just mention SSN and I'll end this command with a semicolon, right? So that's how, guys, you can use the alter table command. You just have to use the keywords alter table and then you have to mention the table's name. And over here, you have to mention whatever action you want to perform, right? So over here, I wanted to add a foreign key. So I just mentioned add foreign key and then I'll mention the attribute name, which has to be mentioned as a foreign key and the reference table name and the column name, right? So once I'm done with that, I'll just execute this command. So as you can see, the action output, your foreign key has been added, right? Now, similarly, if you want to add the foreign keys for the other relationships, that is basically our employee to employee supervision relationship or employee dependence of relationship or works for or works on relationship. So you can basically write commands like this that, you mention alter table and then you mention the database name dot table name, which is not always required as because we are already using the database. you can directly write the table's name. Then you have to use the keywords add foreign key, and then you have to mention the column name which refers to the other table name in the database and the column name. So similarly, as you can see in the screen, I've added so many foreign keys. So let me just run all these queries, right? So as you can see in our action output bar, all our queries have been executed, right? So that's how you can add foreign keys. Let me tell you that, you can see the results in some other way also, which I'll show you with the next query. Now let's go through what all we've gone through. We've gone to the insert command, the use command, the create command, and the alter command, right? Now we can also use the drop command and the update command. So suppose, let's say I want to update the salary of an employee with some SSN, right? So let's say for that, I'll type in the command update employee, that is basically our table's name. And then I'll use the command set, and then I'll mention the column's name in which I have to change the value. So over here, I want to change the salary. So I'll just type in salary is equal to, let's say 27,000, where SSN is equal to, let's choose some SSN randomly. Let's say SSN is equal to 333 4445, right? So I'll just copy this and paste it over here, right? Now, once this is done, I'll just end this command and I'll run this query. So when you run this query, you can see that that the salary has been updated for the employee whose SSN is 333 4445, right? So that's how, guys, you can use the update command. Now suppose if you want to drop any particular table, you just type in drop table and then you'll mention the table's name, right? So suppose I want to drop the table works on. So I'll just type in works on. And if I execute this command, you'll see that our table has been dropped. So let me just show you the action output. You see the action output that our table has been dropped. So since we have dropped our table works on, let's just create a table again so that we have a schema ready for the further queries. So let me just run these commands again and let's just insert the values. All right, so as you can see, I've inserted all the values back to works on again. So guys, that's how you can use the data definition commands, that is basically the create, alter, drop, insert, update commands, right? Now you can also delete a tuple from any of the table, right? So let's say I want to delete a tuple from the works on table where the employee SSN is to be, suppose, let's say this particular SSN, and we also have the project number to be 30, right? So what I'll do is I'll just use the command delete from the table's name, that is works on, and then I'll mention the condition where employee SSN is equal to the SSN that we thought of, that was this, right? So we'll just copy this and let me just put in quotes over here, and also the project number to be 30, right? So for that, you use the keyword and. You just type in and, you'll mention p number is equal to 30. Now, once you're done with that, if you just execute this command, you'll see in the action output that your that particular tuple has been deleted from works on table, right? So guys, that's how you can insert delete tuples also into your tables. Now guys, that was about the data definition commands. Now before I move on with the further hands-on SQL commands, let me just give you an overview of the relational algebra and relational calculus. So basically in this, we have various categories of relational operators. For now, we're going to start with unary relational operators. That is basically the select operation, the project operation, and the rename operation. So the select operation is basically used to choose a subset of tuples from a relation that satisfies a specific condition. So let's say, you mention a condition that, you want all the employees whose salary is greater than 30,000. So you'll see that, when you execute this particular command, you'll get all those tuples with all the information of those employees whose salary is greater than 30,000, right? Now coming to the project operation selects certain columns from the tables and discards the other columns. So suppose, let's say, when you want to select all the employees whose salary is greater than 30,000, but you only want few columns to come in, let's say only the first name and the last name that you want, and you don't want any other information. So then you use this project operation with the select operation, and then you can distinctly get only the first name, last name of all the employees whose salary is greater than 30,000. So don't worry guys, I'll be showing you how that's done. For the select operation, you use the command select, and for the project operation, you use the command distinct, right? Now for the rename operation is basically again a unary operation which is used for renaming the attributes of a relation. So basically, if you have any big attribute names, So suppose in this particular example where I was explaining you guys, I had the manager start date, right? It's quite big. So I can rename it as any small attribute name that can be easily used, right? So that's what the select, project, and the rename operations mean, guys. Next, what we have is the set operations. So as all of us know that set operations are really easy to understand. So in MySQL also we have the union operation, the intersect operation, and the minus operation. So the minus operation is also known as the except operation or the set difference operation. So starting with the union operation, when you have two queries, let's say the left and the right query, and you perform a union operation between both the queries, then it will combine all the rows from both the queries, right? So your output of the union operation will be a combination of all the rows present in both the queries. Now, when you come to the intersect operation, when you perform an intersect operation between the left query and the right query, the output that you get is the common rows in both the queries. So you get only the common tuple values that are present in both the queries, right? So I hope that I'm clear to you guys. Now, the next set operation that we have is the minus operation, or you can say the difference or the except operation. When you perform the minus operation between the left query and the right query, that is basically left query minus the right query, then you'll get all the rows from the left query which are not included in the right query. And it's vice versa. So when you perform the right query minus the left query, then you get all the rows from the right query which are not included in the left query, right? So guys, that's how you can use the set operations also in the SQL commands. So for the union operation, you use the keyword union. For the intersect operation, you use the keyword intersect. And for the minus operation, you use the command except, right? So we'll be doing that very soon. Now, apart from the previous three operations, there's something also known as the Cartesian product operation, right? So the cross product or the Cartesian product between two relations is basically the attributes of one relation followed by each attribute of the other relation. So suppose you have two relations, that is A and B, as you can see on the screen. So the cross product of A and B will result in all the attributes of A followed by each attribute of B. So basically what will happen is that each record of A will pair with every record of B, right? So as you can see on the screen, we have Shania, Atul, Sona with age and sex, and in the B relation we have the ID and the department's name, right? When you cross product these two relations, you can see the output that Shania with age 34 of gender female is followed by the attribute that is 1 and tech. Now similarly, Shania 34F is again followed by 2 and marketing, right? So that's what cross product means. When you cross product two relations, that is A and B, it will result all the attributes of A followed by each attribute of B, right? So I hope that's clear to you guys. So now that you guys have understood the set operations, what cross product is, what basically union, intersect, except is, and also the select, project, and the rename operations, let's just switch back to our workbench and let's just see how we can execute the SQL commands, right? So let's get started with all these commands. So let's get started with the first basic command, that is the select command, right? So suppose you want to retrieve the name and address of all those employees who work for the administration department, right? So what you'll do is you'll just type in select first name and let's say last name from employees, that is basically our employee table, and then you'll mention the where condition. We want to retrieve the data for all those employees who work for the admin department, right? Where the department number is equal to 4, right? So I'll just mention this in quotes. All right, so now once it is done, let's just run this query. And over here, let's go to result grid over here. So as you can see on the screen, you can see that you've got all those employees who work in the admin department. You've retrieved the first name and the last name with the select query. Let's say you also want to retrieve the address. What you'll do is you'll just mention the address column name over here, and then let's just run this query again. So once you run this query, you'll see that you've retrieved the first name, last name, and the address of all those employees who work for the administration department, right? So guys, that's how you can use the select statement. So now let's say you also want to retrieve the data for every project that is located in Houston. You want to list the project number, the controlling department number, the department manager's last name, address, and the birth date, right? So for that, what you'll do is you'll write in a query like this. So you'll just type in select And then over here, you'll mention whatever you want to retrieve, right? We want the project number, so we'll type in P number. We want the controlling department's number, so that is T num. We also want to find out the last name, so that is L name. Then we also want to know the address. We want to know the birth date. Now we want this information to come from 2 to 3 tables, right? We want the project number to come from the project table, the department number to be retrieved from the departments table, and the last name, address, and the birth date to be retrieved from the employee table, right? We'll just type in from, and then we'll mention the table's name. We'll type in project, department, employee, and then you'll mention the condition, right? Where that is why mentioning the where, and then you'll say that the department number in the project table must match the department number in the departments table. So you'll mention that. And you also want to find out the manager's last name, right? So the manager SSN has to match to the employee SSN. So for that, I'll just type in manager SSN is equal to SSN, and also the location should be Houston, right? So I'll just mention that. Right? So with this query, what will be retrieved is the project number, the department's number, the last name of the manager, the address, and the birth date from the projects table, department table, and the employees table will be retrieved, where the department number in the project table should match the department number in the department table, and also the manager's social security number should match to the employee social security number, and also our main condition was that the location should be Houston, right? So now let me just run this query, and let's go and see the output in the results grid. So you can see that the project number, the department number, the last name, address, and the birth date has been retrieved for every project that is located in Houston, right? So guys, that's how you can play around with the select query, where you can mention n number of column names, or where you can mention different tables name through which you want to retrieve the data, right? Now, as I was talking about, the rename operation, if you remember, so what I was telling there was that you can rename any of your column names, right? So suppose if you have any big column name, then you can rename that column name. So let's say we want to write a query to retrieve the data in such a way that, we want to find out the employee's first name and the last name, and also his supervisor's first name and the last name, right? So for that, what you can do is you have to use the as command, right? So basically with the as command, you can see that, you can rename any of your column names. So let me just write the query for you guys. So to retrieve this data, you'll write in select, and let's say e dot first name. That is basically employee dot first name. That is the employee table to be E. And similarly, I'll type in for last name. And for the supervisor attribute, that will be basically identified by the super SSN. I'll just type in s dot first name and s dot last name. From over here comes the main game, guys. So what you have to do is you just type in the table's name, that is employee over here, and over here you'll use the keyword as and mention E. And similarly, you'll type in for the supervisor, right? So what you'll do is, since for supervisors we do not have any separate table, and it is self relationship to the same table, that is the employee table, I'll again mention employee as S, where E dot super SSN is equal to s dot ssn. So what's basically happening here is I'm selecting all those employees' first name and the last name, and also their respective immediate supervisor's first name and the last name from the employee table with the help of the self relationship that we had in our entity relationship diagram. And I'm just renaming the employee table as E for the employee to separate the data of the employees and the supervisors, and this can be identified with the social security numbers, right? So here what I've done is I've just mentioned the super SSN and the SSN. So for every employee who has an immediate supervisor must be equal to for every supervisor who has an immediate employee under him. So I'll just run this command, and then you can see that 7 rows are returned. All right. So as you can see the output, we have got all the details of all the employees who have immediate supervisors, right? So our employees are basically Emma Jawar, Alicia, Franklin, Jennifer, John, Joyce, and Ramesh. And the supervisors' names are as follows, right? So that's how you can perform the rename operation. Now moving on to the project operation, as I mentioned before, the project operation was used when you want to find out the distinct value, or I can say where you only want some columns to be included and not all the columns to be included, right? So what you can do is, suppose you want to write a query where you want to retrieve the data of all the distinct salaries of all the employees. So what you can just simply do is you just have to type in select distinct, and since salary is our column name, we'll type in salary and we'll say from, and then we'll mention employee, right? That is basically our table's name. So let me just run this command for you guys. And now let's see the output. So these are the distinct salaries of all the employees present in the database from this particular query. Now, if you guys remember, I also told you about the cross product, right? So cross product is where when you have two relations. So when you cross product both these relations, the result will be all the attributes of the first relation followed by each attribute of the second relation. So suppose if you want to perform the cross product operation with the help of the SQL commands, let's say we want to select all the combinations of employee SSN and the department's D name in the database, right? So for that, what I'll simply do is I'll choose the select command. I'll type in SSN and D name, right? I'll simply say from employee and department, right? So when I execute this command, you see that the output will be all the combinations of employee SSN and department's D name, right? Let me just run this query. All right, so let me just open the result grid and expand it for you. All right, so as you can see, we've got so many tuples of all the combinations of all the employee SSNs with the department's D name, right? So this is nothing but the cross product. We just chose one attribute in our relation A, that is basically our employee SSN. And in the second query, we chose the department's D name and we've got all the values of them, right? So suppose if we want to change this and let's say we also want the birth dates, right? So I'll just mention birth date over here and let's just run this query. So let me just open the result grid option. And over here, you can see that, the SSN, the birth date, and the D name has been given as an output. So like this, you can perform cross product with the SQL commands, right? Now moving on to one more interesting over here, that is using the asterisk. So when I say asterisk, always remember that it is used to select all, right? So suppose you want to retrieve all the attributes of an employee and the attributes of the department in which he or she works for every employee who works in the headquarters department. So for that, it's really simple. You just type in select and you use asterisk and then you say from, you mention employee and department, that is basically our table's name, and then you mention the condition where our D name is basically headquarters, and then you type in D number is equal to D number, right? Now once this is done, let me just end this query and let me just run this query. Okay. And over here, you have to mention the and command also so that, it considers both the conditions that you've mentioned. Let's just run this query and you can see that, one row has been returned. So let's just check which row has been returned. All right. So you can see that, the first name, middle name, last name, and all the information. That means all the column values of employee and department have been mentioned over here for an employee who works in the department headquarters, right? So that's how, guys, you can use the asterisk also. Now, I think that's enough of the select operations and simple SQL queries, right? Now, let's just quickly jump on to nested queries so that you guys understand what exactly nested queries are, and then you guys can start playing around with your database with nested queries, right? So basically, nested queries, as the name suggests, are those queries which have an outer query and an inner query. So the subquery is a query nested with another query such as select, insert, update, or delete, right? So as you can see on the screen, this is basically our outer query and this section is basically our inner query. So as you can see, we have a query that is select first name, last name from employees where address code in is again a subquery where you have to select the address code from office where the country is India, right? So this kind of queries where you have two different queries connected with each other to give a single output is basically known as nested queries. Let's get started with our nested queries. Now, let's say, we want to make a list of all project numbers for the projects that involve an employee whose last name is, let's say, Narayan, either as a worker or a manager of the department that controls the project, right? So for that, first we have to write a query to make sure that, the last name is Narayan. And then we'll write another query wherein, we'll find out all those project numbers. So let's just start writing the query. So let's say select distinct project number from project department employee, where dnum in the projects table must match the dnum, that is basically the department number in the department, so that is d number, and manager ssn from the employee table should match the ssn of an employee, right? That's because we've mentioned the condition that, that person can be either a worker or a manager, right? It can be either of them, so we also have to mention this particular condition. And also we want the last name to be Narayan, right? So I'll just mention Narayan. All right, so let me just put this in bracket. Now we also want the data of all those employees who are handling the projects, right? So for that, we have to match the employee's social security number to the ESSN that is present in the works on table, so that we know which employee is handling which project, right? So we'll just type in union. That is basically we're using the union operation, and then we'll again type in select distinct. That is we want only few column names, that is P number from project works on and employee, right? So I'll mention all these tables names, where our project number in the project table should match the project number in the works on table. And also what I want is I want the employee SSN in the works on table to match with the employee SSN in the employee table, right? So I'll type in employee SSN is equal to SSN. And over here also I'll include the condition of last name to be Narayan, right? Now once this is done, let's just run this query and check. So this is basically a nested queries, guys. So you can see that, we have an outer query and then we have a subquery, right? So if you see in this matter, this comes something like this. This query will be first executed and then its output will be union to this particular query, right? All right, so when I run this particular query, you'll see that, your one row has been returned. So let's just go to the result grid and see our output. All right, so you can see that, our P number has been returned, that is basically 3, right? So we've retrieved the data of the project number. So that's what we wanted to do, right? We wanted to retrieve the project number for those projects that involve an employee whose last name is basically Narayan, either as a worker or a manager of the department that controls the project, right? So that's how, guys, you can use nested queries. Now let's just quickly do some other nested queries so that you get a hand of it. Now, suppose you want to retrieve the data of all those employees who work the same project and hours combination on some project that the employee Franklin works with, right? So I repeat what I'm going to retrieve the data for. So I'm going to write a query to retrieve the data of all those employees who work the same combination on some project, that is basically the same number of project and hours on some project that the employee Franklin works with, right? So what we'll do is we'll write a select command and we'll say distinct ESSN, so that, we retrieve all the employee SSNs who work similarly, right? From works on, where our project numbers and hours combination should match with those of Mr. Franklin, right? We'll just mention P number and hours. So over here I'm introducing you to an in operator. So with this in operator, what happens is that it will execute this command in such a way that, it has to match with all the queries over here, have to match with all those queries that you mentioned after the in operator, right? So basically what the in operator does is it will allow you to specify multiple values even after the where clause, right? So if you observe over here, we just mentioned one parameter, that is basically, it has to match and all, but we did not mention the combination in any of the previous queries, right? But over here, we're mentioning the combination of the project number and hours. So let's just write our subquery now. So that is basically we'll write again select, and then I have to put it in brackets, and I'll say project number and hours from works on, where our employee ID, that is basically our ESSN, is equal to the employee ID of Franklin, right? So let's just check the employee ID for Franklin. That is basically 333 4445s, right? So I'll just close this and then I'll execute the query. So this is also a nested queries, guys, with the in operator. What's basically happening is we're retrieving all that data of the employees who are working on the same combination of project and hours as that of an employee SSN of 3334445s, right? So let's just run this particular query. So you can see that a query has been executed. So let's just check our output. So as you can see, guys, we have retrieved 3 rows. That means 3 of our employees are working in the same combination of project and the hours as that of the employee as Franklin, right? So guys, that's how you can play around with nested queries. All right. So now, if you want to write a query to find out, the list of managers who at least have one dependent, right? So for that, you have to use the exist operator. So let's just see how you can do that. So let's say, we want to find out the first name and the last name of all the managers who have at least one dependent, right? So for that, I'll write in the query as select first name, last name from employee where exists select star, that is select all basically, from dependent where our SSN of dependent should match to the employee SSN, right? So what I'll do is I'll just say SSN is equal to ESSN, right? So let me just check if it's ESSN or not. Yes, it's ESSN, right? And then I'll close the bracket. And also I want all the managers names, right? So I have to match the manager SSN to the employee SSN also. So for that I'll use the exist operator and say exist select star from department where SSN is equal to manager SSN. Close the bracket over here. All right. So let's just run this particular query and you can see that 2 rows have been returned, right? So let's just go to the result grid and check those 2 queries. So we've got the first name and the last name of the managers who at least have one dependent. Let's just say they do not have any dependent. I'll just change this command to not exist and let's just run this query again, right? So you can see that your query has been executed. So we'll just go to the result grid and you'll see that John Smith is a manager who has nobody dependent on him. So guys, that's how you can play around with the nested queries. Now over here, let's just check some other commands such as the aggregate functions or the like operator, the between operator, and so on, right? So let's get started with those commands now. Now let's say you want to retrieve all employees whose address is Houston, Texas, right? So for that, you'll just type in the command select first name, last name from employee where address, like I said, address should be in Houston, Texas, right? And if you observe the address that you've mentioned in the employee table, you have a variable characters, right? So for such kind of variables, what you can do is you can use the like operator. So you just use the like operator and then you say in quotes percentage Houston Texas percentage, right? So what's basically happening over here is that anything that is even before Houston, Texas or after Houston, Texas will be taken into consideration and all those values will be printed out, right? So let's just run this query. All right, so you can see that you've ran this query. Okay, it says 0 rows returned. That's because we've not given proper spacing. Let's just give proper spacing as we mentioned over here, right? So let me just mention it over here. All right, now let's just run this query again and you'll see that 5 rows have been returned. So let's just go to the result grid. All right, so you can see that John, Franklin, Joyce, James, and Ahmed have the address of Houston, Texas, right? So guys, that's how you can use the like operator. So basically anything that you have before the percentage operator over here and even after the percentage operator over here would be taken into consideration and would be printed out. So the only thing that matters and that has to match the condition is present between the percentage operator. So now suppose if you want to find out all those employees who were born during the 1960s, it's really simple. You just type in select first name, last name, as I want the first name, last name to be retrieved from employees. And I'll say where birth date is basically like I put in quotes. Let's see how I've mentioned the date. So you can see that I've mentioned the date like this, right? So let me just copy this and let me just paste it over here. And now let me tell you over here that you have to remove all this and you have to mention underscores. So let's mention underscores over here. But yes, you have to leave the 6 because you want all those employees data who are born during the 1960s, right? So 60s would be coming over here. So let's just run this query now and see if it runs or not. All right, so now let's go to the result grid and check out our output. So you can see that, Mr. Ramesh, Ahmed, Alicia, and John were born during the 1960s, right? So guys, you can definitely check with your tables that you have and you can review the answer. So that's how, you can use the like operator. Now, suppose, if you want to find out all those employees in the department 4 whose salary is between 10,000 to 40,000, how would you do that? Well, for that, you have to use the between operator. So what you do is you just type in select and use the asterisk so that you select all from employee where salary between 10,000 and 40,000, right? And also a department number must be 4. So I'll just type in department number is equal to 4. So over here, let's just end this query over here and let's just see the output. So once you run this query, you can see that, 2 rows have been returned. So again, let's just check those 2 rows. Okay, so you see that, the first name, middle name, last name of all those employees whose salary is between, 10,000 to 40,000 working in department 4 has been returned. So you can see that, both these people have the salary of 25,000, right? So let's say, you change this to around 20,000 and let's say we change this to 5 and let's run our query again. So you'll see that, around 4 tuples have been returned of 4 different employees who are working in department number 5 and are earning between a salary range of 20,000 to 40,000, right? So that's how, you can use the between operator. Now, after this query, now let's say, you want to write a query to retrieve the data of all those resulting salaries, if every employee working on product Z is given 30% raise, right? So for that, you again use the as operator that I had mentioned before. So you just type in select e dot f name and let's say e dot last name and we say 1.3 because that is 30% raise multiplied by e dot salary as increased salary. So whatever value that we are calculating is being stored in increased salary from employee as E works on as W. And let's say we have the project as P where E dot SSN is equal to W dot SSN. Basically, we're matching the employee's social security number to the project he's working on, basically from the works on table. And then we're also matching the project number, right? So we'll mention and W dot project number is equal to P dot P number. Also make sure that that the product is basically product Z, right? So we'll just mention product's name. So we'll say P dot P name is equal to product Z, right? So this will basically, retrieve all the salaries of all those employees who have got a 30% raise and are basically working on the product Z. So let's just run this particular query. You can see that, 2 rows have been returned. So let's go to the results grid. All right. So you can see the output that, Franklin and Ramesh have been working on the product Z and the increased salaries around 35,000 and 49,400 respectively, right? So that's how, you can use this command. Now let me tell you one more thing over here. You can also use the is operator over here so that, you find out the data whether it exists or not, right? So let's say, we want to retrieve the name of all those employees who do not have supervisors. So when I say they do not have supervisors, that means that value should be null, right? So what I'll do is I'll just simply write the query, select F name, last name from employee, where our super SSN is basically null, right? So that means this query will retrieve all those employees who do not have supervisors. So I hope that's clear. So let's just run this query and see the output. So you see that, 1 row has been returned. So let's just check which row is that. So you can see that this particular employee, that is James, does not have any supervisor. So that was about the different operators such as the between, like, is null. Now let me tell you something about the aggregate functions. Now, all of you must have heard about the aggregate functions, right? What they mean is basically they're just used to perform the mathematical operations. Now, let's say you want to find the sum of salaries of all employees, the maximum salary, the minimum salary, and also the average salary. It's really simple, guys. You just have to type in select, and then you have to use the aggregate function, that is sum, and mention the column name. So that is salary. And similarly, you'll mention max salary, min salary, and also average salary, right? And then you'll mention all this has to be selected from the table's name, that is employee, right? So when you run this query, you'll see that the sum of all salaries, the maximum, minimum, and the average salary has been returned, right? So let's just check that output. So you see that the sum of all the employee salaries around so much. The maximum salary is 55,000, the minimum salary is 25,000, and the average salary for all the employees is 33,500. So guys, this was a really simple basic query. Now guys, you can also count the distinct salaries values in the databases. So with that, you use the count aggregate function. It's really simple. You just type in select count, mention the columns names, that is salary, and over here you mention the keyword that is distinct, because you want a distinct salary from employee. So what you do is you just run this particular query, and then you see the output that you have 6 distinct salaries in the complete database, right? So guys, that was about the aggregate functions. Now moving on, we also have commands that I mentioned for data manipulation, that is the group by, order by, having clauses. So we'll start with the order by clauses, and then eventually we'll go into the group by and the having clauses. So consider a query where you want to retrieve a list of employees and the projects that they're working on, ordered by the department, and within each department, they're ordered alphabetically again by the last name and then the first name, right? So what you'll do is basically you'll select the department's name, the first name, last name of employees, and the project's name, right? So you'll select D dot D name, E dot F name, E dot L name, P dot P name from department, employee, project. And what I want to mention is I have to mention department as D, right? So I'll just type in department D, employee E, project P, works on W. Now where we'll mention all the conditions, that is basically we want to match the department number. So we'll match the department number from the departments table to the department number in the employees table, and also the working SSNs, right? That is basically the employees working on the projects and also the project number. So it's really simple. You just have to type in D dot D number is equal to E dot D num, and E dot SSN is equal to W dot ESSN, and W dot project number is equal to P dot P number, right? Now this has to be ordered by the department, and within each department we want it to be ordered alphabetically by the last name and then the first name, right? So we'll type in order by D name, then we want to mention the last name, so that is E dot L name, and then E dot F name, right? And then I'll close this particular query. So what's basically happening is I'm retrieving the names of the employees, the project name, and the department name on which they work, and they're ordered by department's name, the last name of employees, and the first name alphabetically. So let me just execute this query. All right, so you see that 14 rows have been returned. So let's just check the output. So you can see that, all our tuples have been ordered alphabetically, that is by D name, first name, and the last name. So you see that, first the administration comes, then the headquarters come, and then the research comes. All right. Now, suppose if you want to get the information of all the employees in such a way that, they're ordered by their salaries in the ascending or the descending order, what you just do is you say select star from employees. So that is employee table. And then you say order by salary in the ascending order. So let's say we want them in the ascending order, and then you run this query. You can see that 8 rows have been returned, basically all the entries in your employee table, and all of them are ordered in the ascending order, right? So let me just show you that. So when you see the salaries, you see that you have in 25,000 first coming up, then 27, then 30 and 38, right? So that's how, guys, you can play around with the order by clause. Now coming to the group by clause is basically used to, retrieve the data in a group form. So suppose, for each department, you want to retrieve the department number, the number of employees working in the department, and also the average salaries of employees working in that department. What you simply do is you just type in select dnum, that is count star, and then you say average salary. So count star is basically, to count the number of employees, and average salary is an aggregate function that I had mentioned before. So you just say average salary, and then you say from employee group by department number, right? So basically the values will be grouped by department number. So when you execute this query, you'll basically come to know that you have around 3 departments. So the number of employees working in the 3 departments are 1, 3, 4 respectively, and their average salaries are 55,000, 31,000, and 30,000, right? So that's how, you can play around with the group by clause. Now not only this, you can mention any number of conditions over here. So let's say, you want to retrieve for each project the project number, the project name, the number of employees working on that project. So similarly, you just again write the query like select project number, project name, and count. So that is basically counting the number of employees working in that particular project. And then you say from project and works on table, you say where project number in the project table should match to the P number in the works on table, and they're grouped by the project number and the project name, right? So we'll just type in project number, project name, and now let's just run this query. So when you run this query, you can see that 6 rows have been returned, and all of them are grouped by the project number and the project name, right? So let's just see the output. So you get the output of project number and project name, and you get how many people are working on the projects, right? Now that's how, guys, you can play around with the group by clause. All right, now coming to the having clause. The having clause basically allows you to put in conditions, when you use the group by function. So let's say in the query that we just wrote, we want to retrieve only that data where the count is greater than 2, right? So for that, you just type in having count greater than 2. I'm sorry, I had to mention asterisk also. Yes. So what will happen is this will retrieve only that data where the count is 2 and is also grouped by the P number and the P name, right? So let's just run this particular query. Alright, so if you see this output, you see that you get only 2 tuples, but initially when you did not have this having clause over here, you got all the tuples that were grouped by the P number and the P name, right? So that's how, guys, you can play around with the order by, group by, and the having clauses. Now let's just move on. Let's just go back to our presentation and let's just understand what exactly joins are. So when you talk about joins, as you all know that joins are basically used to combine 2 queries, or you say 2 tables based on the conditions. So basically the default type of join in a join table is called the inner join, where the tuple is included in the result only if the matching tuple exists in the other relation. So basically there are 2 types of joins, guys, that is the natural join and the conditional join. So if you have a natural join between 2 relations or 2 or more relations, then the result will be a set of all those combinations of tuples with equal common attributes. So basically you do not mention any condition over here, you just directly join these 2 tables. So as you can see on the screen, we have the employee table and the department table, right? So what I've done is I've basically performed a natural join between the employee table and the department table. So as you can see on the screen, when you perform the natural join, what has happened is that the common attributes between these 2 tables, that is the department name, has been checked. So you can see that the IT sales are the 2 common values present in both the tables. So when you join these 2 tables, you see that you get only those tuples, where you have equal attributes, right? So you get Shania, Atul, and Abhay in the output, with also the columns of the department, that is the department name and the manager's name, right? So that was about natural join, guys. Now if you see to the conditional join, which is basically you mention any condition, right? So in a natural join, the default condition is that it is equal between the common attribute, while in a conditional join, you have to specify any condition, right? So we have 2 set of tables, that is A and B. Now the condition between A and B is that A's marks should be greater than or equal to B, right? So whenever the A's marks are greater than or equal to B, then when you join these tables, all the attributes of A would be followed by each attributes of B which satisfy this particular condition, right? So you see that 46 is greater than 21, 23. So you see those marks over here. 55 is again greater than 21, 23. You see these marks over here. But 60, yes, is greater than all these three marks. So you see the values of all these three marks with the respective other tuple values, right? So that was about conditional join, guys. Now let me tell you one more thing over here. This is not an end to the story because there are also various other types of joins that you have to understand. That is basically the inner join, the left outer join, the right outer join, and the full outer join. So when you perform inner join in the table, what it returns is that it only pairs the tuples that match the join condition. So that is basically the conditional join that I mentioned. So basically whatever tuples match the condition, only those tuples would be retrieved. But when it comes to the left outer join, the right outer join, and the full outer join, in the case of the left outer join, every tuple in the left table will be appearing in the result, and even if it does not have any matching tuple, it will be padded with the null values for the attributes of the right table. Similarly, for the right outer join, every tuple in the right table will be appearing in the result, and even if it does not have a matching tuple, then it will be padded with the null values for the attributes of the left table. And finally, coming to the full auto join, then this is basically a join which will include the tuples of the left table and also the right table. So that was about the joins, guys. So as you can see on the screen, this is a simple summary of all the joins that you just understood. So I hope that you guys have understood the basic concept of joins. Now let's just go back to our MySQL workbench and let's just see how do we implement joins in the database that we're using. So now let's say, we want to retrieve the name and address of every employee who works for the research department. It's really simple to write. You just type in select and let's say first name, middle name, last name, address from employee, join department. I'm joining the department because our department number has to match between both of these since we have to retrieve the name and address of every employee who works for a department researched, and that research department name is been stored in the department table, right? We'll join the employee table and the department table on D number is equal to D number. That is basically we're trying to match both the department numbers from both the tables, and we'll say where, that is basically a condition, the name is equal to research, right? So when you execute this query, you'll get the name and address of all those employees who are working in the department research. So let's just see the output. Oh, I'm sorry, I missed out a comma, so we didn't get the last name. So let's just run again. All right. So you can see that, John, Franklin, Joyce, and Ramesh have the middle name, last name, and address which have been retrieved. And all these people are working for the department research, right? So that's how, you can use a join. Now let's just see one more query before we move on to the next section. So let's say, we want to retrieve only those employees who have a supervisor, right? So it's clear that, our super assistant whose value will be null will not be included. So for that, you just have to, write a query like select, let's say e dot first name as employee name and s dot l name as supervisor name from employee table, right? So we'll type in employee as e left outer join, again employee as s, and then on e dot ssn is equal to s dot super ssn, right? So you write the query like this. Now let's just run this query again and let's see the output. It says 12 rows have been returned. So you can see that, the employee name and the supervisor's name has been returned. So for every employee who has a supervisor name has been returned. But yes, if there was no supervisor for any particular employees, then null value has been returned, right? Now similarly, if you had applied the right outer join for this particular query, then you would see that, for the supervisors who do not have any employees under them, the null values would be returned over here, right? So that's how, guys, you can play around with joins. So now let's move on to our next topic, that is views. A views basically is a single table which is derived from the other tables. So suppose if you have two tables, so when you pass a query to create views, what will happen is it is a single table which comes as an output, but yes, it is derived from both these tables, right? So you can see that the columns are derived from both these tables, right? So that's what exactly views are. So basically, views are used when you want to understand the tables more and then you want to work on a particular table without disturbing the database, right? So let's just switch back to MySQL workbench. And now let's just, create views over here. So before I start creating views, let me just make you go through the syntax. So suppose if you have to create a view, right? So what you have to do is to create a view, you just have to use the query create view, mention the view name and then use the keyword as, select, mention the columns names that you want to include in your view from the table. So you have to mention the table's name and then you can also mention a condition, right? So to update a view, you again have to type in create or replace view name. You have to mention the view name and then you select, basically write the same query as that of creating view and then you update your view, right? And again, to obviously drop a view, it's really simple. You just have to mention drop view and the view's name, right? So now let's just switch to our MySQL workbench. So let's say, I want to create a view on works on table, right? So I'll just type in create view and I'll mention the view's name. So let's say the view's name is works and I'll say as select and then I'll mention the columns that I want to include, right? So I'll mention first name, last name, project name, number of hours from the employee table, that is for the first name and the last name, the project name from the project table, and the hours from the works on table, right? So I'll just mention works on and then I'll mention the condition, right? So our SSNs have to match, obviously. That is basically a primary key through which we understand which tuple has been uniquely identified. So we'll just type in where SSN is equal to employee SSN of the works on table and also the project number in the project table is equal to the project number in the works on table, right? So once this is done, if you execute your query, your view has been created, right? So that's how you can create a view. So similarly, you can also drop a view. You can just drop this view. So you just have to use the command drop view and let's say works. So when you execute this command, you can see that your view has been dropped and there's no view which exists, right? So guys, that was about the views. Now moving on to triggers. So triggers are basically triggered, when you perform an action, right? So these are basically a set of SQL statements which are stored in the database catalog and are executed or fired whenever an event associated with a table occurs. So basically, you can just understand that a trigger can be invoked either before or after the data is changed by insert, update, or delete statements. So the various kinds of triggers that you can invoke are the before insert, the before update, the after update, the before delete, and after delete. So the before insert is basically activated before the data is inserted into the table. The after insert is activated after the data is inserted into the table. The before update is activated before the data in the table is updated. The after update is activated after the data in the table is updated. Now the before delete is activated before the data is removed from the table and the after delete is activated after the data is removed from the table, right? So that's how guys you can use triggers. So let's just see in our workbench how we can use triggers. So if you have to create a trigger, what you have to do is you have to just simply write create trigger. So suppose we want to create a trigger so that whenever a new employee comes and his salary is updated or inserted, the supervisor of that particular employee comes to know, right? So for that you'll just type in create trigger and you'll give a trigger's name, let's say sal info. Now we'll mention the action that is before insert or update of basically salary, right? So we'll mention salary. The supervisor underscore SSN on employee for each row when new salary is greater than select salary from employee where SSN is equal to new dot supervision SSN, right? And then it has to inform the supervisor. So I'll type in inform underscore supervisor new dot supervisor underscore SSN and new dot SSN, right? So that's a basic example of how you can create triggers, guys. You just have to mention the name and then you have to mention the action and then you have to mention in which condition that you want the trigger to be invoked, right? So that's basically how you can create triggers, guys. Now moving on to the next topic, that is basically transactions. So transactions basically group a set of tasks into a single execution unit. So basically, each transaction begins with a specific task and ends when all the tasks in the group successfully complete, right? So a transaction can have only two results. Either it is a success or it's a failure, right? So there are basically 5 commands related to the transactions. So the first one is the set transaction. So this basically places a name on the transaction. The commit transaction, with this command, you can save all the transactions to the database since the last commit or the rollback command, right? So it's basically like Git, when you commit something that, you can just save it, right? Now, the rollback command, this command can be used to undo the transaction since the last commit or the rollback command that was issued. The save point creates points within the groups of the transactions in which to roll back. And coming to the last one, that is the release save point. This command is used to remove a save point that you have created. So all these commands are basically used to control the transactions. All right, guys, now moving on to the next topic, that is basically timestamps. So timestamps are basically a function which return a date time value based on the given date or date time values. So let's say, we execute this function. So let me just switch back to my workbench. All right, so let's say we type in select timestamp and we mention, let's say 2017 0909, right? All right, so let me just close this and let's just run this particular query. So you can see that, one row has been returned. So let's just go and check that row. So you see that, one row has been returned and you get the date and time value, right? As you've mentioned. So suppose if you had mentioned two expressions, then you would get the value of two expressions, right? So basically, if there are two arguments specified within the function, then it first adds the second argument to the first and afterwards returns a date and time value, right? So that's a basic concept of MySQL. So, guys, that's all for today's session. I hope you found this session informative and I hope you guys have understood data, databases, database management systems, the relational database management systems, and obviously the SQL, right? So, I hope that you guys had a lot of fun, executing the queries. So, guys, that's all from my side today. Thank you and have a great day.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!